All right, so in the past I've shown NEMA standard motors before. This time I am gonna show IEC motor. As you can see here, it's got the bridges and it's an IEC motor. So this motor is connected in the Y configuration, or star if you are talking in IEC terms, and it runs on 400 volts. So with the connection connected like this, it is in the Y or the star connection, and that means that all of my windings should all be connected together internally. So I am gonna make it in this configuration, that way I can, just make it from one phase and hit all of them at the same time. Otherwise, if you disconnect your bridges, you're gonna have to go one by one to test them individually. So step one, take my black lead coming from my insulation tester and put it to the frame of the motor. So I'll put it right there, and take the red lead and put it onto one of the phases. So again, all the windings are connected, so when I put it to here, it's gonna read everything. And because it runs on 400 volts, I'm gonna test it at twice the operating voltage. So I'm gonna set my tester to 1000 volts. And then I'm gonna go ahead and make sure I stand clear away from the leads and go ahead and test. And we are showing a reading of greater than 11 gigaohms. Then this is for you, the people that always get mad in the comment because I tested at 1000 volts and not 500 volts, because they think that 1000 volts is going to damage the motor. I will test it at 500 volts. This one's just for you guys. Greater than 550 mega ohms. And then if you really want to know the overall health of the motor, you can do a PI or polarization index test, or DAR, a dielectric absorption ratio test. But I don't have time to stand here for 10 minutes, so I'm not going to test it that way. And if the motor would be shorted, insulation would be bad, you would pick it up right away with just a regular test. I mean, these tests up here are more for predictive maintenance of how your insulation is wearing down over time. And this is a pretty good chart you can go off by if you're not sure of what kind of mega ohm reading you should see. So I tend to look for anything 10 mega ohms or better, and anything below 10 mega ohms is considered starting to be abnormal. If I make a motor and I see that it is less than 10 mega ohms, I make sure that we have a replacement motor on hand in case it fails. And this chart can be found on the Grundfos motor book. You can Google this book title online and it will show up. It's free right on the internet, so if you have internet access, you can check this book out. It does have a ton of useful information on electric motor, a bunch of stuff you can read and gain some knowledge on. So as always, thank you for tuning in. Until next time, deuces.